Hello everyone, welcome to my channel. Here I will be starting a new series on class 9 mathematics as per NCERT. So let us start with the first chapter, number systems. Let me first draw a number line. This is a number line where I have marked 0, and on the right side I am marking the positive numbers like 1, 2, 3, 4, so on. On the left side, I am marking the negative numbers -1, -2, -3, -4, and so on. Now, I am going to pick up some numbers like 1, 2, 3, 4, and etc. In the number line, this can be shown here. And these numbers are called natural numbers. Denoted by n. These are 1, 2, 3, 4, 5, 6, and so on. Total infinite numbers are there. Now, if I include 0 with these numbers, then the number system will become whole number. And written as W. This consists of 0, 1, 2, 3, 4, so on. So basically, whole number is, this consists of 0 and natural number. So we have covered the numbers on the right side of 0, including 0, 0, 1, 2, 3, 4, etc. Now, what about the numbers on the left side of 0? If we include this, then it will become integers. So let us define integers. Integers are denoted by Z. These are collection of all the numbers started from 0, 1, 2, 3, dot dot dot, and -1, -2, -3, dot dot dot. These are called integers. Now you can see that we have covered all the numbers. In the right side of 0, we have covered the numbers. Also in the left side of 0. Is it so? No. We have forgot to take the decimal numbers or the fractional numbers. Here comes the rational number. The numbers like 1 by 2, 2 by 3, 0.5, 0.6, -3 by 4, -5 by 4, -0.6. These are called rational numbers. And denoted by Q. So what is the definition of rational number? Rational numbers can be written in the form P by Q such that P and Q both are integers and Q is not equal to 0. Why Q is not equal to 0? If q becomes 0, then this thing will be invalid or undefined, because if the denominator becomes 0, then the number will be undefined. That's why q is not equal to 0. So what are the numbers, rational numbers? Is half, 2 by 3, 0.5, 0.6. These are all rational numbers. Remember that these numbers are also comes under rational numbers only. So let us do one example. This is the first example of number system NCERT book, where you have to state which statement is true and which statement is false. First statement is every whole number is a natural number. Second statement is every integer is a rational number. Third statement is every rational number is an integer. So every whole number is a natural number. What are whole numbers? Whole numbers are 0, 1, 2, 3, 4, etc. Is 0 comes under natural number? No. 0 doesn't come under natural number. So the first statement is false. Now the second statement. What about the second? Every integer is rational number. Integers, what are integers? 0, 1, 2, 3, minus 1, 2, 3, and so on. This comes under rational number. So this is true. Every rational number is integer. What are rational numbers? 0, 1, 2, 3, 4, minus 1, 2, 3, half, or 2 by 3, 0.5, all are rational numbers. But all these numbers are not integers. Do you think 1 by 2 is integer? No, this is not integer. So this statement is false. Here one thing to note, that there are infinitely many rational numbers between any two given rational number. Suppose if we consider how many rational numbers are there in between 4 and 10. If you consider how many integers are there, there are only 5, 6, 7, 8, 9. These 5 numbers are there. But rational numbers, there are many. Like this can be 5.1, 5.2, 5.22, 6.1, 6.001, 6.000001, and so on. So infinitely many numbers can exist. Infinitely many rational numbers can exist in between two rational numbers. You have to remember it. Now comes irrational numbers. You can denote it as q dash. These are the numbers which cannot be written in the form of p by q, where p q belongs to z and q is not equal to 0. This cannot be represented by p by q. So what are the examples of the irrational numbers? One favorite example is pi. Another examples are root 2, root 3, root 5, root 10, root 15, all these things. So if I ask you how can you represent the rational numbers in number line, you can easily represent. Suppose if I say like 2.5, you can represent it as this point. This is the middle point in between 2 and 3. This is 2.5. If I ask you to represent the number minus 3.1, if you divide in 10 numbers between 3 minus 3 and minus 4, you can find here somewhere here minus 3.1. But what about these numbers? How can we represent here in the number line? So let us consider root 2. How can I represent it in the number line? So let us, okay, let me take another paper and draw it again. Here 0, 1, 2, here minus 1, minus 2. So let me take suppose this 0 to 1 is 1 unit. Let me take another 1 unit here, and this angle is 90 degree, consider, and say this is O, this is A, this is B. Let me join it here. This is 1 unit, this is 1 unit. So as per Pythagoras law, Pythagoras theorem, we know that OB is equal to OA square plus AB square. So what is OA? That is 1 square plus AB is 1 square, that is equal to root 2. So this is root 2. We have found root 2. Now this is 3, this is 4. Now we have got the number root 2 here. So now how to represent it in the number line? To represent it, you have to use a compass and put it here, like see, compass is like this only. This is one needle one and another one is pencil side. You put this needle here and put the pencil side on B. You put the needle on O, point O, and put the pencil on B. Now then, taking this as a radius, put this line here. Make an arc and come to this line, number line. Now this O B B dash, this O B dash, this represents root 2. Similarly, if you want to represent root 3, then take another 1 unit from point B and at an angle 90 degree. Okay. Now suppose this is point C and join it. Now again from Pythagoras theorem, you can see OC is equal to OB square plus BC square. This BC is 1 unit. OB is root 2. Root 2 square plus BC square 1 square, that is equal to 2 plus 1 is equal to root 3. So this one is equal to root 3. So again, by the compass, if you make an arc and put it on number line, you mark it as C dash, you will get root 3. This is root 3. Again, take unit 1, considering it 90 degree, unit 1, and take point D and join it. So how much will be OD? Suppose this is OD. OD will be OC square plus CD square. How much will be that? Root 3 square plus CD square 1 square, that is equal to 3 plus 1 is equal to root 4. And we know what is root 4. Root 4 is square root of 4 is 2. So to check whether what we are doing is right or not, this is root 4. This should be equal to 2. That is, if we take the compass and put the arc, this should touch the point 2. With minor error, it should touch the point 2. So if we keep on doing things like that, we will get root 4, then we will get root 5. Similarly, we will get root 6, so on. So the figure will be somewhat like 1, this is, and this will be like a spiral. This will I have not been able to draw it properly, but this will be like somewhat like this spiral nature. Okay, so I hope you have understood how to represent the irrational number in number line. Now let us recapitulate what we have learned. Firstly, we have considered natural numbers. Let us take some numbers in a bag. This is called natural numbers. Natural numbers. What are natural numbers? 1, 2, 3, so on. Infinitely many natural numbers are there. Now, if we add in our bucket 0, then the number becomes whole number. Now, this thing becomes whole number when we add 0 with this 1, 2, 3 and so on. Now, if we add the negative numbers also, like -1, -2, -3, -5, -1005, then this becomes integers. Now, if we add the fractional numbers, decimal numbers, like 1 by -1 by 2, 1 by 2, -0.505, 2.312, -6555 by 452, this becomes rational numbers. Then if we take some other numbers like pi, √2, √3, √10, 2 root of 8, √15, this becomes irrational. This doesn't come under this. This will be a separate thing. Irrational. Irrational numbers. And this whole number whole this number system is called real numbers. In number system, this is called real numbers. Other type of numbers are also there. Those are called complex numbers. What are complex numbers? Like square root of -2, square root of -5. These are called complex numbers. You don't need to know all these things now. These are for higher classes. So these are about number systems. Now we will learn these real numbers in a different way, in decimal expressions or expansions. Let us go through some examples. Like you will find the same example in NCERT math book. I am taking the same example. Let us draw the decimal expansions of 10 by 3, 7 by 8 and 1 by 7, and we'll see what happens. If we divide 10 by 3, then first 3 3 is a 9, 1, take the first decimal, then 0, 1, 0, 1, 0. So this will go on. You will find that remainder 1 will be for each and every step it will come. And if we do 10 by 3, and now comes 7 by 8. Now comes 1 by 7. Okay. In the first case, you can see the remainders. These are 1, 1, 1. Always these are 1, 1, 1. And in the second case, the remainders are 6, 4, and then 0. Then stops. And in the third case, the remainders are 3, 2, 6, 4, 5, 1, 3, 2, 6, 4, 5, 1, and this is repeating. Now understand case 1, remainder becomes 0. Which case is this? This case, 7 by 8. Here, this is called rational numbers, and second case, remainder does not become 0. Which case? These two case, this and this case. So, both these cases, these are rational numbers. Here you consider remainders doesn't become 0 in the second case, but remainders are repeating. So this is rational number. So if we consider rational number with respect to decimal expressions, either terminating or non-terminating but recurring or repeating. Now for these three cases, this terminating case, this is true for 7 by 8. Here the quotient is terminating 0.875. After that it stops the division. And non-terminating but recurring or repeating, this case is true for these two, 10 by 3 and 1 by 7. See here 3.3333, this is not terminating but repeating or recurring. Same thing is recurring. Here also this is dotted. See, after 1, 4, 2, 8, 5, 7, the same thing is coming, 1, 4, 2, 8, 5, 7. So here this is also non-terminating. The quotient is non-terminating but repeating or recurring. So this is the definition for rational number with respect to decimal expressions. So now what is the definition of irrational numbers? If we consider the decimal expressions, the definition is the decimal expressions has to be non-terminating and non-recurring, or that is non-repeating. What are some examples of this? Like 0.1245892 dot dot dot. This is irrational numbers. It is non-repeating or non-recurring and also non-terminating. Root 2, if you write the expressions for root 2, this is also non-terminating and non-recurring. Pi, This is also non-terminating and non-recurring, and you cannot write these expressions in the form of p by q. You cannot write it in the form of p by q, where p and q are integers and q not equal to 0. You cannot write it in the form of p by q. All these irrational numbers you cannot write. Now you will say that we know that pi is equal to 22 by 7. We can write pi as in the form of p by q, where p is a integer 22 and q is also integer, that is 7. But you have to remember, pi is not equal to 22 by 7. The value of pi is approximately equal to 22 by 7. We consider it 22 by 7 for our convenience, but value actually we cannot write it as 22 by 7. Okay. Now there is a way of writing these numbers, like 1 by 3, we have written it as 0.333 dot dot dot. We can write it as 0.3 bar. So that means if someone says 0.5 bar, that means it is equal to 0.555 dot dot dot. What if someone says 0.12 bar? That means it is equal to 0.121212 and continuously so on. What if someone says 0.12 and the bar is only on 2, above 2? Then it is 0.1222 dot dot dot. Right? Now let us go to the NCERT example. If someone asks you that let us go through the 7th example, example 7 of NCERT book, where it has been written, show that 0.333 dot dot dot, that is equal to 0.3 bar, can be expressed in the form of p by q, where p and q are integers and q is not equal to 0. Let us consider x is equal to 0.333 dot dot dot. Now we multiply on the both sides with 10. So this will be 10x in here, 10 into 0.333 dot dot dot. Now 10x is equal to, now this 10 will be multiplied with 0.333. So this will become 3.3333 dot dot dot. So now we are going to separate this 3.333. We can write it, can we write it as 3 plus 0.333? See, I think we can write it 3.333 is equal to 3 plus 0.3333. Now this 0.333 dot dot dot, this is equal to x. Here we have considered initially, so we can write it as x. Now that means 9x, we have taken this x this side, 9x is equal to 3. So this x becomes 3 by 9, that is equal to 1 by 3. Similarly, if someone asks me to write 0.4 bar in the form of p by q, what to do? X is equal to 0.4 bar, we will take, is equal to 0.444. Now 10x will be 4.444 dot dot dot. So we can write 10x is equal to 4 plus 0.444 dot dot dot, or again 10x is equal to 4 plus x. This 0.444 will be equal to x. We have considered it initially. Now we have taken this x this side, so 9x will be equal to 4. So x equal to 4 by 9. So now if we consider number 0.12, can we write it in the form p by q? Let's try. Again consider x is equal to 0.12 bar, or x is equal to 0.121212. Remember, if the bar comes on 2 digit, then multiply the x with 100 x. Okay? If the bar comes on 3 digits, then multiply with thousands. Like that you have to think. So this will be equal to 12.121212 dot dot dot. Now 100x is equal to 12 plus 0.1212 dot dot dot, or 100x is equal to 12 plus this 0.1212 is equal to x. We have considered initially is equal to, so we can write it here as x. So we have taken this x this side, 99x is equal to 12. So x is equal to 12 by 99. So can we write that if I need to write a number such as 0. If we write it as a bar in the form of p by q, will it not be a by 9? See, if we replace this a with 4, then it will be equal to 4 by 9. If we replace this with 3, then it will be 3 by 9. Now if we say the number is 0.ab bar, we have to write it in the form of p by q. Will it not be in the form of ab by 99? A is one digit and b is another digit. Now you try by yourself. If you want to write it in the form of, if we want to write a b c bar in the form of p by q, it will be a b c by 999. Similarly it goes on. If you write a b c d e in the form of p by q, so it will be a b c d e. How many zeros will be there after 1? 1 2 3 4 5. 1 2 3 4 5. Okay. Now let us go through the example 9 of NCERT book. Show that 0.235335 dot 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 is equal to 0.235 bar can be expressed in the form of PQ, where PQ are integers and Q is not equal to 0. Here the 35 is repeating or recurring. So the bar will be above 3 and 5 only. So now let us consider x is equal to 0.235 bar. That is x is equal to 0.2353535 dot dot dot. So what I have told earlier, that if the bar is on the above the 2 digits, then we have to multiply x with 100. If the bar is on 3 digits, we have to multiply x with 1000, and so on. It will be like that. So if we multiply with 100, what will be? 23.53535 3535 dot dot dot. 100x equal to, now we are taking 23 out, and 0.5353535 dot dot dot. 100x equal to, so making it this one, our aim is to make it as x. To make it as x, what we have to do, 23 plus, we have to take 0.3 outside. So can we write it as 0.3 plus 0.2353535 dot dot dot? Think it. I have just taken 0.3 from these numbers. If we add 0.3 with these numbers, this will become 0.5353535. So 100x will be equal to 23.3. I'm adding these two. And now this one, what is this? This is equal to x. We have considered initially. So I have written it as x. So now 100x minus x is equal to 23.3. Now 99x is equal to 23.3. Now x is equal to 23.3 by 99 is equal to 233 by 990. I hope you have understood up to this, and now to get it more to get more clarity, I am showing you another one chart. To remember the number systems, please remember this chart. If you please take a screenshot of this chart, you may understand by looking at this chart, you will understand everything. What we have studied, we have gone from bottom to top. Like first we have taken natural number, that is all positive integers 1 2 3 4. Then if we add 0 with this natural number, then we got whole number 0 and all positive integers. Now all positive integers, now the whole number and the negative integers, these two are making integers such as -3, -2, -1, 0, 1, 2, 3, 4, etc. Now if I consider this integers and non-integers, these two are making rational numbers, and rational and irrational numbers are making real numbers. Here the non-integers are also divided into two terms, terminating and non-terminating. What is terminating? 1.1, 1.5, 1.2 minus 3.2. But this non-terminating, this is non-terminating and recurring. This can be said as 0.3, 0.666, 0.3 bars, 0.666, 2.152, 152, 152 dot 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 1 by 3, etc. And what are irrational numbers? Numbers which cannot be written in the form of p by q form, which are in decimal expressions. We can say that these are decimals are non-terminating, non-recurring, such as √2, √3, pi, minus √5, etc. So I am closing this video today, but the chapter is not fully completed. We will do in next video. Thank you, and please support the channel.